In last class, at the end of the lecture, I portrayed some kind of an equation that how we can compose the real life problem in form of equation. For example, if we are dealing with some fruit, for example 2 apples and 3 bananas from some shop, we want to buy this number of fruits and we are paying total sum 90 rupees for this. This is the one problem, one format you can say. But what will happen if we want to determine that what is the exact price for apples from this equation? Shopkeeper do not tell us, our machine deep learning automatically determine the exact value of this. We need to check out the similar kind of example in the surroundings. As I demonstrated in Russian example, for getting a house on our end or for buying purpose, we are visiting too many houses. Basically, similar nature of example need to be determined. So in this case, we need to check out the surroundings, shops of fruit, and we need to check out the rates. But with this exactly, maybe this amount, okay, number of coefficient of apple, that amount of apple can be increased or decreased, but it should be the combination of apples and banana. If we are dealing with oranges or something pineapple fruit, then we need to describe okay, another set of equation. So we are visiting some another shop for checking out the price. So maybe 10 apple and we are ordering, okay, so maybe 1 banana and he is charging 110 to us. So now there are two number of equations. For better accuracy, deep learning, I will explain a little bit later, that huge data will give us the more accurate result. So with this setup, we can make a matrix formation, and matrix formation is very simple, like 2, 3, 10, 1, coefficient A, B, 90, 110. Either with the help of row elimination method, Cramer rules, basic simple matrix theory, we can get a solution set, and solution set, this is A and this is B. I think it's very simple. Moreover, once we are talking about the determinants in math, we already talked about the inverses. Okay, yes please.
सर वो जो एग्जांपल आपने दी सर, इसको तो हम सिंपल तरीके से भी कर सकते हैं, लाइक तो हम मैट्रिक्स में क्यों पढ़ रहे हैं, मतलब मैट्रिक्स पे हम क्यों जा रहे हैं?
If you are having only two examples, you need to determine the point with the help of point of intersection, that you can do it. But real life scenario, you are dealing with thousands equations, okay, thousand number of here, apple, banana, maybe some oranges, maybe okay, variety 100 fruits you are determining, okay, and you are observing for better accuracy, you are observing the all our shops in, okay, Amazon. What Amazon do? Amazon do the huge market, okay. Amazon give a challenge that if someone is selling this product on the lower price than us, then tell us, we will make it at that price. Give us the reference of that exact shop, then we will make this product price according to that level. So this is the challenge of Amazon. That's why Amazon is getting success day by day. So what did he do? Amazon do? Amazon is okay, analysis. Do the better analysis with huge, okay. This is not only two equations. Once you will deal with the 1000 equations, then that simple method will not work amicably. Is it okay? Thank you. So I already talked about the inverses. I think Inverse of the matrix, yes. Inverse of the matrix is used once you need to get back the original shape. Okay, original model, original things. And determinants. Determinants tells us the prediction things. For example, last day, some weather. Okay, you are talking about weather. So there are four elements of the weather. One is the rain, another is the sunshine, third one is the humidity, and or you can say other suffocation level. These are four parameters. We are checking our mobile phone. Okay, last day, with the help of determinant, it tells us that how much day was cold or how much it was hot. Okay, but you also determine today. So another, okay, similar parameter as in previous examples I explained, you need to consider the similar nature of elements. Here you need to consider the similar nature of elements, humidity, rain, sunshine, okay, suffocation level. So prime, B, C, okay, not prime, it can create trouble for people. It is about today. We are getting the determinant of it. Determinant of last day gave us a result that 25 degrees centigrade. Today it tells us about, this is give us single scalar value, determinant. Okay, so maybe 27 degrees centigrade. We want to predict about tomorrow. If there is no, okay, of course, if the rain is on the diagonal or some parameter is heat effect, maybe it will say tomorrow it will rain, but with a knife sense, very simple approach, we can say temperature is getting hotter day by day. Okay, deep learning, observing with the help of matrix theory. Is it clear, please? Yes. So, one more thing about the application of inverse. Okay, today I will recall in term field of cryptography. For example, you want to transmit some important message to your fellows, or maybe you are working in defense forces, you want to transmit some message to the fellows at the border area, and you want to encrypt that message so that intruders, enemies, spies could not get it clearly. Okay, you want to send it in encrypted form, coded form, okay, in cipher domain. For this purpose, your matrix theory is helping out in field and make it more robust. Robust, you can say strong enough. Okay, with the application of deep learning. But the basic concept is this. For example, we are dealing, or we are sending some message to our fellows that let's meet tomorrow. Simple message. Okay, if we want to send this message, computing system do not know the alphabets. Computer system follow the numeric values. If we think in terms of numeric values, we can think some kind of integer, decimal. Okay, for simplicity purpose, I am dealing with the integers. What is this? These are the alphabets of English, and there are total 26 alphabets. Okay, if we transform according to the alphabet in form of integer values, we can say This one is some numeric value which can be, you can say, in alphabet arrangement, okay, in order. Its M is at 13th place, T is at 5th place, 20th place, 15th place, 13th place, 15th place, and somewhere 18th place, 15th place, and 23rd place. Okay, so we can consider it as a single, okay, vector, or we can decompose it into the small fragment of a vector for simplicity purpose. Okay, one thing I would like to inform you people: don't bother the space. No need to assign any numeric value to space, because in Urdu script, are we using some kind of space in words, among words? No space. We are native, we can easily read it, okay? Though native English people is portraying some kind of space, but technically, if you are a native English speaker, you can easily, okay, discriminate, you can break the sentence, okay? Simple sentence. So it doesn't matter about the space. You can, in the word between meet and tomorrow, no need of space, just consider, okay, combine. So decompose, for simplicity purpose, let's decompose into the three okay, element in one array, okay, one vector. So we can make here 13, 5, 5. This is x1, okay, x1. Similarly, x2, 20, 20, 15, x3. I am not following the basic. Okay, now you are grown up, so mathematics you need to play with it. 13, 15, 18, x4, you can say 18, 15, 23. These are four vectors. We are decomposing this long vector for simplicity purpose. Now we need to get some key matrix, and key matrix, you can say this is a matrix. It will with you as well as at the destination point. Once you will transmit this message, you will not transmit this key matrix with it. Key matrix will encrypt these original vectors in some kind of a dummy data, okay, so that spy intruders could not get it easily. So for this matrix, of course, 3 by 3 according to the multiplication rule, 1, 2, 3, you can say 1, 1, 2, 0, 1, 2. Now transformation is required. Transformation of x1, x2, x3, x4. So mathematics, the word L is used for transformation from 3-dimensional to 3-dimensional, because we are having 3 elements in this one vector, or you can say there are 3 rows. Okay, number of two column is 1, 3 rows. Okay, so we consider this matrix in form of 3 by 3. So our, yes please.
So how we get the matrix A?
Matrix A, random, totally random. You can consider this value of 200, 3000, 500, totally random. Okay,
It's our encryption
it's kind of a
key.
secret thing.
This is our encryption key. We can
Encryption key, exactly. This is your encryption key. You can design it by yourself according to your choice. It can be anything. but this is should be the same with your partner, okay, at the destination point. So what will happen here? You will get a new vector x1 prime by transformation of, or you can say by multiplying of T matrix with x1. Okay, so if we multiply it, one, two, three, 1, 1, 2, 0, 1, 2. Your first vector x1, 13, 5, 5. You will get a new vector if you will multiply this 1, 2. Okay, here you can say that 13 plus 5 plus 5. Similarly here.
Sir,
13
plus 10.
13 plus 10, no, 13 plus 5, 5 plus 10, and here 0 plus 5 plus 10.
So first,
Okay, yes, first is 10 here. Is it
15,
okay?
15, sir, last is 15.
Last is 15. Okay, is it clear now?
Yes, sir.
The first one will become 38 and second one will become what? It's 28 and this one is a 15. So this one is your transformed, or you can say encrypted vector. Similarly, you will get
X.
Can we apply any mathematical rule, like instead of multiplication, like can we use addition, subtraction, division?
No. I will let you know why we don't need to do addition, okay? If you will do addition, you came to know your password will not become strong enough. Okay? There is something, but because we will use the inverse at the destination point. Inverse matrix, application of inverse. Simple addition, there is kind of some scalar value, so this is not too robust. Robust means that intruder or spy should not get it easily. So the second one become 105, 70, 50. Okay, maybe in exam I will ask from you people. So this is, if you will multiply this with the third one, you will get an answer like 97, 64, 51. Similarly, your x4, of course, will be achieved by multiplying with x4 original. Okay, x4 prime will be achieved by this, so you will get 179 and 61. These are your encrypted coded message. So this will not be easily decrypt until there is no traitor among you people who can leak the key. Okay, and at the destination point, what will happen? You will get your x1 by multiplying A inverse with x prime. So if you want to notice it, you can see I determined the A inverse. A inverse 0, 1, minus 1, 2, minus 2, minus 1, minus 1, 1, 1. You will multiply it with modified 38, 28, 15. This is our x1 prime, and evaluating it further, 0 plus 28 minus 15, and what will be happen here? Okay, 76 minus 56 minus 15, so minus 38 plus 28 and plus 15, you will get 13. What's here? 6, 7,
76 minus 71. 5.
Okay, here 20 or 5 and 5. This is your original message. Okay, you will retrieve your original message, meet me. Okay, deep learning, okay, will enhance the scheme. This is a very simple thing. Okay, even the images, huge matrix, huge, you can say, plot or enemy mapping or some other technological advanced algorithms. Okay, so all these things are.
Sir,
Yes, please.
we change meet tomorrow in numeric form,
Yes, please.
alphabetic to numeric.
Yes, please.
Any kind of other things, images, videos, we change in numeric to trans.
Yes, we can do it. We can do it. Anything can be happened. Videos are what? Videos are basically frames of images. Okay? See, you are in videos, you noticed one image with continuous, okay, just fraction of second, you will get another image, then fraction of second, okay, you will get another images, like we are, if we get a, okay, match box with match, okay, stick, if we are lightening it, we just rotate the matchstick, okay, in a circle, we will get, we see some kind of a ring, okay, red ring. What is this basically? This is some kind of a point of the matchstick, but due to our eye observation, limited eye observation, we see that this is kind of a continuous pattern, though this is a discrete pattern, but time is too short, so it looks like a continuous pattern. Okay, similarly, in video, there are images, okay, frames, they are passing through in front of us, so we are observing it is such kind of a video, but technically these are the frames, these are the images. So if we can transform what I told you in start, matrix is the replica of image, like pixels, matrix element is the pixel value, okay, brightness value. So if we can encrypt the image, similarly we encrypt the video. Okay, thank you. In last class, or you can say in first of our lecture, we talked about some kind of a equation of line, slope. But why I am emphasizing on these concepts? Because without these concepts, you could not proceed further in deep learning. You cannot get the grip of deep learning until you don't know the basics of it. In deep learning, there are 4 things. One is the statistics. At the top, another is calculus, another one is probability, and linear algebra. very core concepts. In statistics, we are dealing the analysis. Okay? In probability, we are determining the prediction likelihood, okay, occurring of the chances. And in calculus, you are optimizing your model. Okay? It's with its derivative information, with its integral information, and linear algebra, you are observing how the algorithms will run with feasible mode. These are the 4 segments of deep learning. You need to know, I am not touching too much statistics because Dr. Arif is already teaching, but this will little linear algebra, calculus, probability. Once you will become little bit master of it, then deep learning is just a game, fun for you people. Okay? So, in start, I spoke out about the equation of line, and I highlighted the concept of slope. Okay, if we see here in this, this one is the equation of simple slope, and if we are talking about the simple equation of slope, you can say that some change along x-axis and some change along y-axis, you will name it as a slope, or you can say m equal to rise, okay, along y-axis, our run change along the x-axis. But this is the simple linear case. What will happen? This is a linear model, okay, very simple model along the line. You can get its average. But once you will deal with some polynomials, this is not a linear model. In this model, you see, if you make a plot, and of course here y x squared. If for the one value of x you will get one value, for two value of x you will get double, for three value of x you will get triple. Kind of a polynomial things, okay? So not kind of a line. See, you will get some kind of a pair for 1 point, okay, here for 1 you will get 1, for 2 you will get 4, for 3 you will get some, okay, 9. So this is, you will get some kind of parabola here. Some kind of a, you can say that whiskey glass, okay, so this shape. So to deal this, we, though there is a slope, okay, there is a slope, but we need to know some kind of delta x approaches to 0. Once we will apply this delta x approaches to 0, some kind of a limit, delta x approaches to 0, then it will become small, okay, this will become derivative, small change. And this small change is known as equation of, equation of tangent line. Because we are talking about only 1 point. See here, if we zoom this 1 point, we will understand that this is not the average change. This is basically very small change. So if we are determining the small change of it, dy over dx, then it will tell us some kind of this thing. Okay, so for one value of, so it is kind of some doubling concept. This is the concept of change, but important thing is this, how it is utilized in deep learning. Deep learning, it is playing with regression theory. Did you study about regression? First of all, please note down the definition of data set. Data set, please note down this definition. Okay, when information is used for prediction, when information is used, though I should not write it, but used for prediction, the possible value at certain locations are known as data set. Data set basically what it is, kind of some information, okay, information that is used for prediction for the possible values, okay, at certain locations, at certain positions. This is a data set. For example, we are visiting to Punjab Pass or somewhere there, okay, on some visit with fellows. We are collecting, okay, taking pictures on the way. So at different locations, we are, okay, getting pictures, and of course, possible prediction that this is the Mansehra, this is the Bisham, this is the Gilgit, okay. So it is, and this all, okay, information is what? Data set. So in deep learning, we are, yes please.
सर यहाँ पे टर्म इंफॉर्मेशन यूज हुआ है, तो सर हम डेटा को यूज करके इंफॉर्मेशन नहीं लेते, लाइक हमारे पास एक बड़ा डेटा होता है, जिस तरह आपने कहा डेटा,
Yes.
तो डेटा को यूज करके हम यूजफुल इंफॉर्मेशन लेते हैं, मतलब हमारे पास पिछला एक डेटा होता है और उसके बेस पे हम इंफॉर्मेशन लेते हैं. तो यहाँ पे हमने यूज किया कि व्हेन इंफॉर्मेशन इज यूज, तो यहाँ पे डेटा नहीं आएगा सर.
Yeah, very good. And actually, in start of the class, I told you that we need to assemble a data, okay, from the existing information. Like deep learning mimic the brain, okay. So child is saying Papa, Mama. First, someone tell him, her that Papa, Mama. So then child is speaking out like this. You familiar with this? The children who are deaf, they cannot speak, okay? First information should be fed, then information should be retrieved. You can get the information. I am so sorry if I did not explain well, but this is the concept, okay? Is it clear a little bit?
Yeah, actually he is confused
Yes,
in
please.
terms of data and information.
Yes, sir.
Data is in the form of raw things
Raw.
from which we calculate information,
Yeah.
reduce.
Here, when information is used for prediction,
Whereas we are saying that data set, so data set is itself set of known information, so we call it information.
yeah, it is your okay, again prediction.
Yeah.
Your prediction because you have this kind of knowledge. Yeah, but here what in this definition we want to say that possible values, not the exact values,
Yeah.
possible values of the information. Okay, we may have 1,000 pictures, but maybe few pictures at few, okay, positions or locations. Though every picture will contain some information, but not all possible. Okay, so will be deal as a data set, so that it can help out. Okay, for example, we are observing the camera images, but in data set of camera images, we are using some dog images, we are using the elephant images. These are the useless. Okay, then we need to consider only the camera images of variety, okay, different varieties.
सर जिस तरह मुझे ना जो कंफ्यूजन है वो इंफॉर्मेशन पे लाइक सर ये क्लास है, इसमें हमारे पास मतलब बड़े मतलब कई जगह के लोग हैं, हम अगर उसके लिए कहें कि ट्रांसपोर्ट का वो करना तो हम सबसे पहले इंफॉर्मेशन लेंगे, तो वो जब हम इंफॉर्मेशन लेंगे, जब वो इंफॉर्मेशन हर बंदे की आएगी वो हमारे पास डेटा नहीं आएगा फिर
This is the same thing.
लेकिन सर वो डेटा सेट जो यहाँ पे इंफॉर्मेशन यहाँ पे मुझे थोड़ी समझ नहीं आ रही, कंफ्यूजन।
You want to say here when data set is used for, you want to say it should be like this?
क्योंकि सर जो डेटा सेट हमारे पास होते हैं रॉ डेटा नहीं होता हमारे पास, इंफॉर्मेशन तो एग्जैक्ट मतलब जो हमारे पास एक्यूरेट होती है उस
No, information
set-
can be okay.
Like information is the output of processed data.
यस सर।
डाटा सेट इज़ ऑलरेडी एक प्रोसेस इंफॉर्मेशन होती है, मिसाल के तौर पे हमारे पास डाटा सेट है वेदर का, उसमें ह्यूमिडिटी और वो सारी चीज़ें मिला के अब ये पता होता है कि रेन है, तो उसकी बेस पे हम प्रेडिक्ट करते हैं कि ये कल क्या होगा। तो डाटा सेट जो होती है वो ऑलरेडी एक इन्फॉर्मेशन होती है जिसकी बेस पे प्रेडिक्शन करते हैं।
Can you please read out one more time this? Okay, let me read out. Listen, please. When information is used for prediction, this is one part of the information is used for prediction. If you say when data set is used for prediction, there are two different theories. First one, information is used for prediction. Second one is a data set is used for prediction. From where you will get data set? If we mention here data set for prediction. Okay, from where you will get data set? Some information.
Yes sir.
So I'm talking about that information. Okay. So if of course once you will have a data set, then you don't need to get information from anywhere else. Okay, from raw data, as he told us about the process. Yes, I absolutely agree. Okay, this is the thing. I think we should not waste our precious time on this. This is okay. You can manipulate it. It's kind of a word, but not the chronic verses. Okay, you can change it for your choice. Our core concept is to understand is there. Okay, for example, let's consider some simple example. Okay, about farming, market. You know, once farmers are working hard in the fields, they do not get the proper, okay, dues of their struggle. People in the market, okay, you can say that get a benefit. So there are certain stages of it. First one, for example, farmers are growing some kind of a fruit. At the farmer location, there are various let me talk about the locations. Farmer location, home location, it is about 4,000. Okay, it can be any kind of grass product, any kind of fruit, any kind of quantity. So price is, we are talking about price 4,000, and once this product is reaching to the village main market, price becomes 12,000. When it is reaching to the city, nearby city, price becomes 28,000. Once the same product is reaching to the capital of some country or area, capital area, the price becomes 52K, and one it is going to export, okay, to the foreign countries. Foreign price becomes 80K, as we are getting the petrol. Like this. So originally price was 4,000, though it is not exactly the 4,000, but farmer calculated it according to its farmer expenses, some hard work, some labor charges, but profits, but till the foreign market price is this one. These are different locations. Information, these are the possible informations. But somewhere you want to know what should be the price. Farmer is going to sell that product, but from farmer home to the city area, or you can say from village to city area, somewhere there in center, you are stopping the vehicle and you are requesting, I want to buy this product, what will be the price of this? Here, all these 5 places, price is fixed, or you can say kind of a benchmark thing. So this is amount charges, but somewhere in mid you want to determine its price, you want to predict its price. This concept is known as regression. Here, and in this regression, for example, you are total location. First point. This is the first point, first location. Price is 4,000, and that last point, fifth point. This is the fifth point. Fifth location. X5, Y5, then X5, Y5, 580. So what you need to do, you need to determine the slope M. According to the slope criteria, what is final? Y2 minus y final minus y initial. Similarly, x final minus x initial. In this case, we will have y5 minus y1, x5 minus x1, and somewhere you will get a value by substituting this in all the situation. Is it okay? This is not the benchmark value. 19 is not existing anywhere. This is a prediction, but with mathematical formulae of slope. And slope, a moment ago I told you it is kind of a straight line. Until we want to apply limit delta x approaches to 0. This is the just generalized guess, 19, but you don't want to get any loss. You want to pay the very sufficient, or you can say very precise amount, so that you can sell it further, after market thing. So the concept is this is the average thing. This prediction is not accurate one. This is very general thing. On somewhere you apply a slope, but for precision you need to apply the derivative. Apply some kind of that delta x approaches to 0. So this concept of derivative, and once you will apply the derivative, there will some kind of error. This is the some kind of predicted, and maybe by applying the derivative you will get 17. Then in start of the lecture I told you y2 minus y1, some kind of this minimum scale error kind of thing. Norms, I taught you about norms. we applied norms so that this error between 17 and 19 should be minimized. Okay? So this gap should be minimized. We need to know about it. We will study. And this is the concept of regression, that how we can minimize it. Okay? First, how we can predict, and then how we can analyze with the help of exact derivative by applying precise. Then we want to minimize this big error margin, okay, so that the value should be adjusted amicably. In this, we will also notice somewhere there are two factors. One is the location, another is the price. Somewhere we will use the partial derivative. So we are only talking about the location importance. In this situation, for example, some function will have two parameters, okay? Two things. One is the location, another is the price. And you can say price is going with this fashion as location. Okay, location is changing with this fashion and price is changing with square, and location is changing cube wise. Okay, after 3 kilometers price will becomes double. Okay, are you getting the point? So this is, but here you want to talk only about the location, then you will apply partial derivative 3x square. And if you want to talk about the price only, then partial derivative with respect to y, so it will give you this thing. Okay, if it is little bit, let me make it simple. For example, you are talking about some house, number of bedrooms, and okay, area. There are, I'm talking about some house, one is the number of bedrooms, another one is the area. And in this case, we say the situation is look like this. Bedroom, okay, with this formation, and area scale in this formation. We want to know if there are number of bedrooms. Okay, we want, okay, this one here function is what? It's the price. It is telling the price of the house. This function is showing some kind of price. Okay, we will say partial derivative price with, okay, here bedroom. So we will get 3 bedroom square. Okay, if you will talk about the area, then price twice the area. Okay, in previous case I said that the after cube, okay, this distance will be, for example, 1, okay, 2, or you can say the cube of the distance will change, the price will become double. So if here the changing of the area is giving, but in partial sense. Sometimes you need to know the one factor you are not considering. For example, transportation is free, then you want to check out that what is happening there. So deep learning is playing different factor in different domain. Okay. and this is telling that how much price is changing of the house, if changing of the area or changing in the number of bedrooms. This will tell us partially. Similarly, many other basic applications can be noticed. For example, charge is flowing through some capacitor or some kind of a electric wire, some systems. Change of the charge, okay, per unit time will give us some current, value of a current. Moreover, Newton talked about the concept of derivative in terms of speed and velocity. Very beautiful concept. If you are going to teach somewhere the mathematics, you should know this very basic concept. For example, if you are covering some distance with respect to time and you want some of your friends notice how fast you are going, what is your speed. At that moment, of course, he will say, you are looking so fast. At that moment, he observes you. At some other time, maybe you are, okay, strolling very, okay, your walk is very much slow, but sometimes you are in hurry. So your friend is observing at that particular moment, this is, at this speed, it is your velocity. Once car is at static position, you are turning on the car is changing its position from origin, from static position to some another point, and it is in running mode after some, okay, in some unit time, some short span of time, then it is velocity. Then you want to change the velocity. What you need to do, you need to press the accelerator. And this accelerator pressing, that what is changing in this accelerator? Velocity. Velocity is changing with respect to time, and it is known as the acceleration. Okay, first one, simple distance is changed. It is telling your speed is changed, okay, from static to some, okay, in run position in short span of time. So this is velocity, and so your velocity is changing, then it will become acceleration, okay? And remember, this time should be, okay, big, basically unit time approaches to 0. It's not for all the, okay, for all the moments. It is for very short span of time. Somewhere you are okay, you are touching some cup or some teapot which is very hot. In a fraction of second, you are, okay, getting away from it, and you say this is basically, it's too hot. Basically, this is this thing. Deep learning concepts are observing it in the frame of gradient descent. And if in this gradient descent, important thing is about the tangent line. Okay, a moment ago I have shown you people by zooming out some point, because the system is not more linear. System becomes non-linear. Okay, in almost all of the problems are usually complex problems are some kind of a non-linear. Okay, polynomial setup. So, if polynomial setup, then power of x can be changed. For simplicity, we say it can be n can be any power of 100, 1, 2, 3, 4, okay, greater than 1. So this is some function. So you want to get the derivative of this function is some kind of like price is something, okay, changing a thing. So it is changing n minus 1. How? This is the well-known power formulae, okay, in the derivative terms. Or you can say power rule. If we see how it happens, we can consider the very simple example of this. For example, we can expand it or we can prove it with reference of slope. Reference of slope is very simple, that we need to consider this is the y-axis and this is the x-axis, and change in this scenario, okay, the y-axis, this is the final and this one is the original, and of course in the denominator there is some change along x-axis, and we know what is the function here. It is, in the previous case, consider this one, x power n. If we are considering the n here in this scenario, we will consider x plus delta x n minus x n delta x as it is. You need to expand this term. You need to expand this term with the help of binomial theorem. According to the definition of binomial theorem, n can be any number, okay, as I told you, 1, 2, 3, but until n. And by applying the binomial theorem, basically you are factorizing this term x plus delta x n. You are writing it like x plus delta x, x plus delta x. There are too many multiples, or you can say n multiples of this term. Or for example, here if you have 2 square, you will write 2, okay, 2, 3, you will write 2, 2, 2. Similarly 2 and you will write too many, okay, 2. So this is like this, and once you are further multiplying the terms, you will get x n plus n x n minus 1, okay, delta x plus n minus 1 n minus 2 delta x square, somewhere 2 factorial, okay, too many terms, or you can say higher. Once you will multiply again and again one factor with another, then it will become, okay, higher orders. And at the last we will have this one minus xn in denominator. Consider delta x as it is, and on this side you will have. So what you want to do, basically you want to transform this delta x approaches to 0, but not exactly 0, approaches to 0. Okay, for example, if you are running a bike or some car, if there is a jump, speed breaker, you will apply brakes, but you will not exactly abruptly, okay, stop the car 100%. Even there is some vibration in car, it is in running position, but approaching to 0, you are, okay, controlling it, so not exactly 0, and this is somewhere you will notice n approaches to infinite value. I will explain you what this term infinite, okay, but some In this set, we will talk about the integral. If I want to explain about it, I would like to start it from very simple. For example, you are getting some kind of internet signal strength. Sometimes you are downloading some movie from some particular time, okay, from start to end. Somewhere, if you are observing the data received in signal packet 1 MB, somewhere 2 MB, somewhere 0.5 MB, somewhere 1.5 MB. All this is kind of a variation, but in a nutshell, you can say that total MB you downloaded for some movie, for some data, is telling you the net information, sum of information, and this sum of information is integral. And usually mathematical formation, it is abbreviated, or you can say it is mentioned like this, from some point A to point B. Of course, if it is some signal along x-axis, and f of x is the height. You know that y is a function of x. Y is a function of your peak, signal strength. Height of signal strength, as you can say, the capacity of signal strength increasing or decreasing along the x-axis, so it's the height. Basically, f of x is height, or you can say y somewhere. In book, you will also see this kind of notion. Then, for integration purpose, you need to transform the derivative of y in form of x, because it's along x-axis, function of x basically. So, this integrand, this sign, this sign comes from sum. I already explained. So this is a simple generic concept of the integral. Let's talk about it a little bit in detail. For example, you want to do some work, and in this work you want to push some block from position A to some another position to B. Of course, on a floor, on the x-axis, you will drag it or push it, some force will be applied, and this force can be decomposed into its component. One is the vertical component of the force, another is the horizontal component of force. So this distance, covered D, and your work done. Once you will say your work done kind of this formation. And you are applying some trigonometric ratio. This is the base. Base over hypotenuse is telling us, because along the x-axis, giving you what? Cos theta. Base fx over f, or you can say this one will become f cos theta. You will substitute this here, f cos theta, and again the direction of this force component f of x and movement, distance covered in the parallel to one another. So fx parallel to d distance covered. So both, angle basically is 0 between them, and once the angle is 0, you will get fd. However, if I want to explain this in some kind of a movement of a car, that car is traveling some distance from point A to point B, then the situation of car movement will be observed like this.
The driver feels
Release
comfortable
the
in the car
accelerator,
and
then
that you
its
can
speed will
drive
become
that
decreased again,
kind of speed
and at
without
some
any
point
risk.
it will stop. Okay, so you can see its speed. You notice sometimes force becomes zero. Force applied force, you release the accelerator, force becomes zero. Okay. So in variation,
Wow, guys, what a fantastic car. Thank you, grazie, merci. Oh, thank you very much.
now it is stopping again. Okay. This is the beautiful concept which is very important to understand.
तो शेयरिंग करेंगे सर
Okay, that's okay. Thank you. So we will get a graph, and this graph, okay, once car is at rest position, okay, here car is at this position. Graph is going like this, and when it is releasing the accelerator up till it's stopping, graph becomes like this. Okay, once car achieves the maximum position, okay, gradually, okay, sometimes you can say graph can be, its peak can be sharp, but follows this kind of a pattern. This kind of a pattern is known as, then stop again, okay, speed is decreasing. So this kind of a graph is known as Gaussian. This curve, Gaussian, normal curve. Natural Gaussian natural curve is also, it is known as varieties of name, but this bell curve, okay, somewhere it is also known as bell curve. It is very much popular in all the deep learning applications. Why? See, once some students are appeared in KPK medical entry test, not now this. So graph of the students' result is look like this. Did you notice somewhere? Not, never. If you will check, if some students appear in some huge number of students appeared in some exam, you will see the graph of their look like this.
Board exam results.
Yes, board exam results. Let me explain to you how it is happening. Why it is known as also natural Gaussian natural curve. For example, 17. Okay, this is the. I don't need to explain the curve. You got it, the concept. Okay. For example, there are 18,000 students. Maybe some students will not appear in the exam. They missed. Of course, they will get 0 score. Some students may appear in the exam, though they are having the FSC passing criteria, but due to certain sickness, they did not perform well or they left early. They get 10 score. Total score is 400. Okay, appear student 18,000. Some, okay, here you can say that is the along this one is the 18 is okay 1000. This one is the graph number of students, and this one is the score. Students who achieved somewhere 100 score, they are maybe higher, they 125, 150 like this, and average student, there are too many average students everywhere around the globe. Too many average students. Only few, very few, maybe only one student who will get 400 out of 400, or maybe not 390 like this. And maybe few students, 4 or 5 students are on second rank, and 7 or 8 students on third rank are, so graph is going again. And again, average are in center. This is the bell curve. So once you will get this is the natural information.
So on the x-axis, how will we grade the values? Like from 0 to
400,
0?
400 like this. Okay. Got it?
Yes.
Thank you. So similarly, this you are pushing the block here from this position to this position. Somewhere in middle, is your force applied, maximum until then you will reduce your force, and then gradually it will become stop. So like this. Now exact amount of force will not be calculated. What you will need to do, you need to determine the amount of force under this curve. For this, you need to slice up, partition the area. And you need to consider, for precision purpose, you need to slicing infinite partitions and approaches to infinite. Such that if this point is A, this point is B, and you want to, this along the x-axis, delta x, you say B is the final, A is the origin. Of course, you should divide it by total number of partitions. For example, I have 100 rupee bills. I want to partition this 100 rupee into the bills of 10. Then I will divide 100 by 10. Then how many bills I will get of 10? 10 bills. If I want to get 1 rupee, then I will divide 100 by 100. If I want to decrease the scale, and this is the n, infinite, for better accuracy, for better precision, so you will divide by n. And A is what you can say, A is 0, so this is B over n. And once you say n approaches to infinite value, if you are substituting n approaches, not exactly infinite, please try to understand. N approaches to infinite, then this delta x approaches to 0. In my previous first lecture, I told you that I will explain about this concept. So somewhere in books, they said that n approaches to infinite, and some said delta x approaches to 0. This is the concept. Is it clear, please? So now this concept of the work done, and you will partition it, and technically you will get work. Basically, this is the change in work. Change in work, or you want to determine the overall work. This is the small change in work. And this small sum of the work, you will get this. As what we did, this into the small partitions. This work into the small partitions. Delta x approaches to 0, delta x approaches to 0, it becomes dx. Okay, so you are this one, okay, you want to determine the amount of work. This is a small amount of work at one rectangle, okay, at one small instance, or you can say position. You want to sum up all the work. What you need to do, you need to sum up all the rectangles, and you need to multiply this with this small increment change, and you will get net work. This work. And technically, this sum of the work is equivalent to this summation started from 1 to n, where these are the force, or that is the change, okay, and basically this one is the base, okay, or you can say height, and this one is the base, and by applying this amount of work, you will cover this amount of area. This amount of area by pushing block A to B. However, this is the one side, or you can say very simple thing, but if you see in complex formation, you can also notice if there is some area, you can say scale, there is some box. If the exact amount of this, okay, suppose x is a fixed, some 10, then you are getting third dimension of it. This is x, this is x, this is x. Of course, you will get volume from volume. But usually it's not happen in real life. X is acting like a variable and it is changing. So x is changing with unpredicted mood, and we need to observe the change of x in form of, okay, this change, that force, okay, amount of force is not exactly same at all the point. So we need to apply the integral. And if you are applying integral on this scale, then you will get this result. Though this is not the volume, this is kind of a cone. Integral is clear to you, these basic things?
Yes.
Clear or not? These are very basic mathematics. So,
So in integral we bring the power to the base and then reduce it by 1?
yes, power rule, if you want to say here, for example, x n dx, then it's kind of 1 over n plus 1 x n plus 1. In derivative case, okay, we are subtracting one away, so this is the thing. So, how it's happened? For example, let me consider this. Okay, here again in this formula, in this case, we need to determine area under the curve, basically, and then we will get some kind of a cone volume here. But how? For this, let me consider this kind of a cone. Okay, it's not exactly like a cone, but I am considering on exemplary base as Gaussian natural curve, so it can be sharp or whatsoever. So along x-axis we are partitioning it. Remember, the partition should be of same size. As a moment ago I explained that we partition 100 rupee built into 10 notes, each of 10, each of 1 rupee. Each, okay, this one, this, okay, it's should be of same length. Suppose this point, starting point is A or B, okay, this one is the point some B, and of course, but for getting better accuracy, we need to partition in n numbers. That should be infinite. Okay, too many numbers technically. So the change basically B minus A over n. Basically each represent this small change. So whatever delta x, each are same, okay, of same length. Base is of same length. Base of each rectangle is of same length, but height of each rectangle is different. So according to integral formula, Riemann integral, we need to determine area under the curve. Riemann integral, area under the curve. For this reason, what we need to do is this Riemann integral concept is the same moment ago I explained it. Let me follow this for getting area. We sum up all these are the kind of areas, okay, or you can say this is the net area and it is sum of A1 plus A2 plus A3 plus AN. So there are n rectangles, we need to determine n area, A sub n areas, we need to sum up all. This is saying this. And base is, okay, in each case, base is same, and you know if there is a is 0, then we will get delta x B over n. This is the base. So base each is the base is B over n, B over n. But okay, these number of rectangles will change 1, 2, 3, 4 to n rectangles. Here in this case, this is x square. Okay, we want to make a table for this formation of rectangle which are in square formation. So here this will be changed for first, okay, in this I am talking about the height, because this is, okay, height is a function of x. So first one, base this one, so we need to consider 1b over n square, or you can say b square over n square. For second rectangle, this one, you need to consider 2 square b square over n square. Similarly, go to n number of rectangles. N square b square over n square. So for getting area, what we need to do, we need to multiply base into height. Okay, base into height. Okay, first one, plus base into height of the second one. As I told you, base will be same for n. Okay. So it will go like this. B over n is the base. Remember, the height first one is 1b square over n square. Again, base is the same. Height will become 2 square b square over n square. Similarly, for nth, base will same. Height will n square b square over n square. So we will get area like this, multiplying with this one, okay, first one, it will become b cube, okay, or one you can say, we can write it as it is, or in denominator n cube, n cube, you can write one as it is just for, even you cannot write, that's not a big issue, but you can write. So again, 2 square b square or b cube over n cube. N square b cube over n cube. Suppose, okay, see why I put this here, see you can, this will multiply with 2 square, here b will multiply b square, it will become b cube, n will multiply n square, it will become n cube. Similarly here, b n square is as it is, b multiplied b square in denominator, it will become n cube. So this one, now there is a one term which is triggering us, b cube over n cube, and we can see 1 plus 2 square plus 3 square plus n square. Oh, okay, for simplicity, it does not matter if we can make some arrangement like this. Is it clear?
Yes.
Okay, label this at equation 1. Now, this can be some number, arbitrary number, can be 100, can be 10, can be anything. N is the number of partition, it can be anything. But what are these?
This is a number.
Huh?
Number.
Number, but these are kind of a scale. This is a 1 scale, this is a 2 scale, this is a 3 scale, this is a n scale. Let's make it. Okay, let's 1 scale plus 2 scale plus 3 scale plus n minus 1 scale plus n scale. So, aerial view with some drone. Suppose there is some pyramid, so there is a one big scale. If there are too many scales, then you can consider only the inner one. This is 2 by 2, and there is one smaller scale, 1 by 1. Aerial view with the help of some drone, you can see this is kind of a pyramid. Okay, the lower one, the bigger one, so small one, at the top smaller scale. If you want to notice it by side view, you can see at the ground. It's the same color. This is the sided view, and this one is n minus 1. So there are too many scales. So there is some, you can say, 2 by 2, one-sided, okay, one-sided view. And after this, there is smaller one. Is it clear? Now, we want to measure its volume. There are three formation, okay, sided view. We can understand this is kind of a, now one we will have a pile of too many variable, x is changing. At each point x is changing. So, for example, these are A4 size pages. Once we will have too many A1, okay, for single page. For a single page, its thickness is negligible. Suppose it is kind of square. And each square is, okay, though we are considering the same, but will have pile up of too many pages, we will get some volume here. Okay? For a moment, consider these are the pile up of blocks. The first one of a bigger size, then okay, decreasing, of smaller unit size at the top. So it is kind of a volumetric form, like pile up of pages get a volume. So it is getting some volume. So for this reason, let me choose. Okay, there are three possibilities. First one is the inner volume. Of course, it is visibly or visually we can inspect it. It is very much smaller than the exact formation of the block. This volume will be smaller in, so inner volume will be smaller. Or if there is very much accurate, okay, you can say that exactly, you can say then it may be equal, but not greater in any case. So, second one is the exact arrangement of the block, zigzag pattern. The volume of exact volume. This one is the exact one, okay, it can be written as it is, and I do not need to. So the other one is the outer volume. Outer volume, if I will consider the outer one, so of course it will be greater than the exact, and of course the one outer volume. There are three possibilities. One is the inner, other one is the exact volume of the blocks, the third one is the outer one. Now, if we see the inner one, of course, this one, okay, inner one, then base, okay, inner one, we can notice the base square. This one is the n into n square, third one is the height, then we can write 3, okay, there are, you can say that according to the volume of a cone, what is the formula? 1/3 length into height into width. So we will write here 1/3 length into width into height. Second one is the exact one. Exact one is this one, given to you people in kind of a sum up of squares. Sum up of squares. We will write 1 square plus 2 square plus n square. The outer volume is a little bit tricky one. See, exact n, okay, n will be here from this point, okay, please consider. Height is height is 1 unit, increased. This is the exact blue one, top is the exact volume, okay, of the blocks. But by considering the outer frame, we are consider this one is the 1 unit is increased until here it's the n, but there is a now it will become n plus 1. Similarly, on side node, check out on the side node 0.5 on one side, 0.5 on other side. Okay, so it look like that, but technically it's not. It's C smaller one. It's not 1. It's 0.5 on one side, 0.5 on other side. So both are, after adding up, this will become n plus 1. Now it is again a cone, volume of a cone. So we will write one lower one. Okay, here n plus 1, of course, n plus 1. So this is a square 1/3 n plus 1 square. The other one is the height side. Okay, third volumetric height. So it's n plus 1. So our situation look like this. The inner one is 1/3 n cube. Exact one is 1 square plus 2 square plus 3 square plus n square. The outer one is 1/3 n plus 1 cube. Now we can divide, okay, by dividing n cube to all this side, this one will become 1/3 1 square plus 2 square plus n square n cube, and here we will get 1/3 n plus 1 cube divided by n cube. Once we will have this kind of formation, we can write like n plus 1 n whole cube, and further we can write n over n plus 1 over n, and it will be cancelled out 3, and okay, we will have here 1/3 1 plus 1 over n cube. So this side we will have 1/3, and this is exact like this. Okay, for getting the accuracy, okay, what kind of accuracy? If we are considering the pyramid, or we are piling up the blocks such that its variation is too small, or we are partitioning n into infinite value, n into infinite, then of course we will get 1/3 square plus 2 square plus n square n cube, and here this will become 0, and we will get 1/3. Any query in this, please? Not clear. What we did, we construct from the blocks. See, I said there is some scale, okay? There is some scale. There is some scale. We want to integrate it. We want to integrate it from some point A to B, and we know A is 0, or you can say simply from 0 to B. X is varying. X is varying, but dx is too small, so we consider n approaches to infinite on the way. In the outer volume, n approaches to infinite, so this is the situation we get. Then our both side here, this, okay, here n approaches to infinite due to dx, small increment, small change, not a big one. So our left hand side equivalent to right hand side. In your, if you will teach somewhere or you will notice somewhere, there is a sandwich theorem in intermediate notebooks, where they are determining the area of a sector. This is some kind of a sector, for example, some part of the circle. They are considering one inner triangle, and there is some extended, some, okay, so this is the area of a sector. So this is the outer inner triangle, A, B, C, D, E. One is the inner triangle A, B, C, less than, it is too small, okay, very, it can be equal, area of a sector, and its outer triangle, of course, greater than area of a sector, is the triangle AED. Area of triangle AED. So they said if the triangle ABC equivalent to triangle AED, then your area of sector equivalent to, they both are the same. For example, this is 1, this is also equivalent to 1. Your area of sector equivalent to 1. Left hand limit equivalent to the right hand limit. Because if you see, it's very small. For example, it's, okay, here very small, outer or inner almost at the same point. So you can say it like this, is the same. So here we have the same situation according to the sandwich theorem. Your left hand side limit equivalent to your right hand side. So you can say your exact, this will equivalent to 1/3. Yes, exact volume. Thank you so much for correcting. So 1 square, 2 square plus this n square, this equivalent to 1/3. What we did, because it was given to us, there was the x square. We need to sum up from 0 to b with small thickness, small change of the dx, small increment. So we are considered it in this way, and we noticed this one is equivalent to 1/3, and we can substitute this 1/3 in equation 1 somewhere here, this equation 1. So this can be written like p cube 1 square plus 2 square plus 3 square plus n square. This n cube can be written like this, and we will replace this value with deduced value of 1/3, and we will get b cube 1/3, or you can say b cube over 3. This is the volume of cone. See, if we are not considering dx, delta x, okay, delta x too big, then we will notice this kind of a pattern. If delta x stacking is too small, if delta x approaches to 0, not 0, very small, okay, as I told you, then we will see dx, small change, and this looks like pyramid. What happened? At the ground there is a big scale, at the top there is a tiny scale, small. So deep learning help us to observe the thing, but at the back end they are using the integral for summation purpose. For observation purpose at an instant, deep learning is using the derivative. And for regression purpose, for prediction purpose, deep learning is using the regression. So let me explain it more for your clarity. For example, sometimes, okay, sometimes you will see you are dealing with some function integral of x, simple x. If you are integrating it according to its formulae, it will give you an answer like x square over 2 plus c. One thing I forget, I really apologize. There is something I forget to tell you. I know it. Okay, here. Oh, I did not save it, unfortunately. So b cube over 3 plus c. C are what? Constants, but constants of approximation where we cannot predict the exact area. Small negligible things. Small negligible things in derivative are these things. Derivative, antiderivative, integral is the opposite of the derivative, so you are ignoring it. Constant are these things. Derivative of constant always 0. So in other case, once you are summing up the area under the curve, or you are trying to observe some information, you will see this kind of things. Okay, C, constant plus C. Usually so machines sometimes have little errors. So this kind of information, some cryptocurrency. Once you are buying some Bitcoin and selling it, or even after selling, you will see some minute value is still there. This is some kind of a not covering by the summation. Your total.
C represents small triangles over the.
Yeah, exactly. So if there is a, for example, so triangle here, this is the area or somewhere. So this is triangle. This area, which is not covered, which is not calculated. Okay, though with the help of, in case of pyramid, what I did, I consider inner volume, I consider outer volume, I consider exact volume, but still there are chances. Okay, so we cannot basically it's what? Approximation, but very educated approximation.
Sir, how we decrease chances?
Chances, as I told you, partition slices, okay, and
Size, increase
yes.
this partition.
Yes, okay, decrease the size of partitions. I'll show you just one. I need to explain a little bit. I'm sorry. So, for example, if only some x, in this case, it will become x square over 2. What is this? Basically, if you have some, for example, if 0 to some b, of course, this is the original point A, or you can say 0 to some point b, and you can notice it here, it's 0 to b, okay, you need to substitute here, okay, b square over 2 plus 0 whatsoever, so here b square over 2, so you can notice this one is your function of y, this is f of x, this is some height, and your height is what? Your height is this one, and your height basically x. Okay, in previous case we were dealing with x square, here with only x, and our x is what? Basically height is 0 to b, so you can say it's b. And what is this? Basically this is some kind of a right angle triangle, and according to, of course, on horizontal it is also x, okay, or you can say delta x, not x, b minus 0 over n, or you can say in negligible case only you will have b, okay, and just ignore it. In previous cases we cancelled out n, okay, so only b, and here f of x, this f of x is what? B, x, simple. So in the along the x-axis, delta x equivalent to b, so height is also b. You know the formulae of right angle triangle, half into base into height is the formulae of this right angle triangle. So you will get B into B or B square over 2. Question? Okay. Similarly, if sometimes you are considering the derivative of constant is 0, and if you are finding the integral of constant, then you will see some, okay, if there is 0 to b, then you will say some x 0 to b, or you will see some answer b. Do you know what it is? It is very simple. See, from this point 0 to some point along the x-axis, okay, it's b. Delta x technically is b. But what is the height? This is the height. In previous case, we were dealing the height x. Is okay, the b. Here the 1. 1. So this is rectangle. Okay, area of a rectangle 1 into x or 1 into b equal to b. Answer is b. So what is telling this? There is no change basically. Okay, step function. Light is turned off or light is turned on until you do not change. Okay, it is in the static pattern. Okay, everywhere it's 1, 1, 1, 1, 1, 1, 1. Or somewhere it will become 0, 0, 0, 0, 0. This is integral. Sorry, I'm wasting your time, but since in start of the lecture, I also explained this one. I have shown you people the okay, computer tomography. I have shown this to you people in start of lecture. Do you remember? No, it's my fault. So as I told you that the patient, okay, you can read it out. Okay, so linear explanation of slices of issue by measuring the transmitted X-ray intensity through the human body, okay, in form of slice. Capture the slice. And once there is slicing, of course, human body, its slice is kind of some kind of a matrix, some kind of an image. And one, the gamma rays, okay, what here projections, this first projection, gamma rays projection, sum up the value element A plus B, C plus D. Sum up. And then again, in diagram, okay, it is rotating. Camera is rotating around the body in CT scan, computerized tomography. Again rotating, okay, rotating. Body is taken away. Patient is not in a machine now. Information is start, my child, I told you in data set. First we achieve the data from some, now information is no. Okay, now this is the data set. Okay, we need to retrieve back the information. So how? We will put it back. Now there are too many coefficient kind of things. So sum up all. There are 3 A's will be cancelled out. Okay, there are other patterns the same in all the, okay, just kick out. Matrix theory. And you will get this and you will get this back, though there is no patient. And this will tell you, okay, as some I told you in some with angle projection, you will get this kind of formation, integral. For better accuracy, your gamma rays should be very close to one another. For better accuracy. You will sum up all the gamma rays. Sum up. Okay, it is rotating, so sum up all the informations around the body to different angles. So you will get some kind of a sinogram. This is a sinogram, is kind of a data set. Okay, from this data set, you will retrieve Okay, so basically you want to, again, what you want to slice up, okay, the information. Like basically you are observing slice to slice. Clinical expert neurosurgeon will check first slice of the tomography, second slice, third slice, fourth slice. Each where information can be varied. So it is retrieving and it will give you there is some theory, so you can get its effect. But deep learning, how deep learning do? Deep learning predict somewhere in middle with the help of regression theory. For example, deep learning, here somewhere, why deep learning is very useful? Somewhere here, predict somewhere here. Even you did not observe, you did not use the gamma rays at this part. Okay? In start of example, that price at the former position, price at the fifth location. So with the help of slope average change, but delta x approaches to zero somewhere, gives you the precise information at an instant.
Regression.
Yes, regression prediction will happen. Okay? Not clear?
Yes.
We will, okay, see, I will revise with simple examples. You should not worry, but you know, this is somehow a requirement of deep learning. But don't forget these, okay? Please don't forget. We will emphasize it, and we will use these things time to time in our. So this is basic preliminary hour today. And next lecture, I will consider one model. Okay, we will see how to get the pseudo inverse, and then we will go that question. Any question, please, regarding to
Regression is always used for prediction, or there?
No,
is
there
there
are
other-
many possibilities you can use, but technically the definition, okay, you should check out from the Google or Wikipedia, you will conclude it is for prediction purpose. Regression analysis, basically the words completed regression analysis.
And is this for specific problem domain?
No, for any problem domain. This is very broad term, that's why I said that Dr. Arif may have taught you people. This is a very basic thing. Statistic. They're like statistic in start somewhere. I have shown you people statistic is for analysis. And this is from the statistic term. I'm sorry, if there is any confusion at some part, I can revise. I would like to explain it again, please, somewhere.
Right now it's clear, but in future maybe.
No. You come on, okay? I am recording these lectures. I want to increase my viewership, and you are my viewers on YouTube. So I will try to compose it and I will
I'm a
upload it.
regular visitor.
Yeah, no, that's okay. It's up to you, but.